Do you remember in Algebra 2 when you did P over Q and you hated it? Do you know where the P over Q came from? You don't know what I'm talking about. Who was your Algebra 2 teacher? Okay, wait. Okay. We are not going to do P over Q the way you did it in Algebra 2. Do you remember you would do, especially if you were in pre-AP Algebra 2, you would do like a page working on one problem. We're not going back there, all right? I promise you. All that I'm going to show you on this single page that you have is where the P and Q, where all of those possibilities come from, okay? That's all I'm going to show you. Did you figure it out? Good. How many of you factor by guess and check? Sometimes. What other methods do you use? Box. Okay. Good. Let's do guess and check. But let's do it this way. You have factored enough that most of you ought to be able to do that within about 30 seconds. Some of you probably already have it factored in your head. No, not yet. Okay. Here's what I'm going to do. I'm going to pretend that you do not know how to factor, and I'm going to show you all of the different possibilities we would have if we factored this by guess and check. Okay? So, I'd say, well, 3x squared factors into 3x times x. And then I would say, well, my signs have to be, right, my signs have to be different. Now, I don't know if the plus goes with the 3x or if the plus goes with the x. So I might have 3x plus and a 3x minus, right? But I might have a 3x minus and an x plus, right? Now, the factors of 6, well, I know it could be 2 and 3. Do I know where the 2 goes and where the 3 goes? No, so I'm just going to guess. I could put the 2 here and the 3 here, but I could put the 3 here and the, hang on a minute, let me do this better. Let me do it like this. But I could put the 3 here and the 2 here, right? But what if those signs aren't right? What if it's 3x minus 2 and x plus 3? Or 3x minus 3 and x plus 2? And then you say, well, but 6 will also factor into 6 and 1. So I might have all 4 of these setups, but 6 and 1 instead of 2 and 3. So it might be, so it might be 3x plus and x minus, and it might be 6 and 1. But it might also be 1 and 6. How many different options have I got here? Let me see here. And then I could flip the signs. Thank you. Because I knew I was missing something. I knew all these lines had to be filled. But it could be 3x minus 6 and x plus 1. Or it could be 3x minus 1 and x plus 6. Yeah, I know. Those are all the possible ways that I could do guess and check. And then I'd have to say, well, crap, which one works, right? Which one works? Which one gives me 3x squared plus 17x minus 6? The last one. That was not on purpose, I promise. It wasn't on purpose. Now, so this would have been a guess and check option, right? What would the roots have been, or the zeros have been, with that option? Not negative 3/2. Negative 2/3, because you'd subtract 2 and divide by 3. So x would have equaled negative 2/3 or 3. Here, what would x have equaled? 4. Here, what would x have equaled? What about here? Okay. Here? From the equation of f of x, what are all the factors of the constant term? So go back and look at the constant term, which is what? Negative 6. What are all the ways that, or excuse me, what are all the numbers that go into 6? Plus or minus 1, 2, 3, and 6. Because I can divide 6 by positive 6 or negative 6. From the equation, what are all the factors of the leading coefficient, which I believe was 3? What are all the numbers that will go into 3? 1 and 3, so plus or minus 1 and plus or minus 3. Again, because positive 3 will go into 3 and negative 3 will go into 3. Now, we're going to take each factor of the constant term and divide by each factor of the leading coefficient. That's where you generated your P over Q in Algebra 2. Remember? If we do that, so let's do that. I promise I'm going to make it as painless as possible. I'd have 1 over 1, right? I'd have 1 over 3. I'd have 2 over 1. I'd have 2 over 3. Do you see where I'm getting everything? I'd have 3 over 1. I'd have 3 over 3, but that's 1, and I've already got that written down. I'd have 6 over 1, and I'd have 6 over 3, which is 2, which I already have written down. We're going to compare this list with these. Ladies and gentlemen, they're the same list. So when you do P over, what was that? When you did P over Q in Algebra 2, what you were doing was finding all of the possible rational, well, we're not going to say that, all the possible nice roots of that function, okay? And it comes from the fact that these are all the different possible ways that we might be able to factor that thing with guess and check. Now, we know only one works, right? We know this is the only one that works, so we know the only roots are 1/3 and -6. But these were all the possibilities. It all comes from how were you able to guess and check all the different options. That is all I wanted to show you from day 28. You notice it says the rational root theorem. The rational, you're not going to even have to remember this, but the rational root theorem says that the only possible roots of a function are the factors of the constant divided by the factors of the leading coefficient. That if there are factors, they're going, if there are zeros, they're going to come out of that list. So, real roots can be one of two types. You can have real roots that are rational or irrational. Do you know the difference? Some. A rational number is any number that you can write as a fraction. Can I write 0.4 as a fraction? How? Sure. Can I write 0.75 as a fraction? How? 3/4. Can I write 0.998 as a fraction? 998 over 1,000. Can I write the square root of 2 as a fraction? And don't tell me square root of 2 over 1. No, I cannot write square root of 2 as a fraction. Now, another way that you can think of it as it is a decimal that never, back up. A rational number can be written as a fraction, or a terminating decimal, or a repeating decimal. A terminating decimal is a decimal that ends. 0.998 ends. A repeating decimal, 0.3 with the bar over it, that's a repeating decimal, because what fraction does 0.3 repeating mean? 1/3. Now, so an irrational number, here's what an irrational number is. It's any number that cannot be written as a fraction, or a repeating decimal, or a terminating decimal. Square root of 2, if you, and I haven't done it in many years, thank goodness, because we have calculators now. You can't write the square root of 2 as a decimal that ends or repeats. Pi, you cannot write pi as a number that ends or repeats. You can keep going out forever, and you will never find a section that repeats over and over and over. I wouldn't do that. No, I didn't do that. It is a piece of tape. We're talking about something on my board, so I'm going to stop this for a minute. So now, we got to get back to this. Consider the graph of the function that's pictured below. Now, what things make sense about this graph after you look at the equation? So look at the equation, then look at the graph and say, oh, okay, I expected that to happen. 4 zeros, okay? What else did you expect? Okay, what about the end behavior? Up on both sides. Why do you expect that? Even degree and positive leading coefficient. Good. Can you find one more thing? That's what I was looking for. Y-intercept. Y-intercept. Good. Now listen, you don't have to write all this stuff down if you don't want to. I'm going to post the filled in notes. Now, what conclusion can you draw about the 4 roots of the function? There are 2 positive real roots and 2 negative real roots, And I heard somebody else say something else, but I didn't catch the whole thing. What'd you say?
Oh, they all have a multiplicity of 1.
Well done. They all have a multiplicity of 1. Good. Well done. The goal of this lesson is to use the rational root theorem, that's P over Q, to aid us in finding all of the roots of a function, whether they be rational, irrational, or imaginary. Okay, so make a list of all the rational roots that the rational root theorem guarantees are possible. What would your numerator, what could your numerator possibly be? Where does the numerator come from? The factors of 9. So plus or minus 1, plus or minus 3, plus or minus 9, all over. Where does the denominator come from? The leading coefficient. What are all the factors of the leading coefficient? No. So what would this give me? Plus or minus 1, plus or minus 1/3, plus or minus 3, plus or minus 1, 9, and 3. From this list, which roots appear to be roots? Which roots appear to be roots? 3 appears to be a root. Maybe the negative 1/3, maybe? Maybe that's negative 1/3? 1 2/3 is not on this list. Is there anything else on this list that might work? I don't see any. Okay, so 3 and negative 1/3 might work. Perform synthetic division to verify that they are in fact roots. Which one of those do you feel the most confident about? I agree. Let's do synthetic division with 3. I forgot the thing. 3, negative 8, negative. I'm not going to remember that. Let me get my notes here. 3, negative 8, negative 12, 24, and 9. Okay, let's do synthetic division. Are you doing synthetic division? And we say, hurrah, because we know that 3 is a root. Because we get a remainder of 0. Well done. Now, let's see if negative 1/3 is a root. But don't start from the very beginning. Mark that one off, and let's see if negative 1/3, you betcha. You bet you can do that. Three times negative 1/3. Dun, 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 dun. Dun, 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 dun. Okay, now, what do we have left? What does this stand for as a polynomial? 3x squared. Say again, 3x squared? Minus 9. I could do a couple different things. If I want to find the zeros from this, I could factor out a 3 as a GCF, or I could add 9 to both sides, divide by 3, and take the square root. It doesn't matter. You'll get the same answers. 3x squared equal 9. Plus or minus. Indeed. It is irrational. Indeed, woohoo. So look at what our four roots are. Plus or minus root 3, negative 1/3, and 3. We know we have four distinct or different roots because we saw that the graph crossed the x-axis 4 different times. Question? Same way, but you're never gonna. That's right, what we're talking about. So we found our four roots, and notice we were able to peg this one and this one. Those were rational, and these two were irrational. Is that the end of that page? No, I just wrote over stuff, didn't I? All right, so you have just divided a degree 4 function twice so that your resulting polynomial, after we divided synthetically by 3 and by negative 1/3, what was the degree of that answer? It was quadratic, wasn't it? 3x squared minus 9? It was quadratic. The function's roots will be the remaining two roots, which will be irrational. And we found those because we found them as plus or minus square root 3. Next page. Next page. All right, here we go. Consider that function. What do you notice about this graph that does not make sense based on the degree? Oh, the degree is 4, but the function only crosses the x-axis twice. Makes absolutely no sense. Could it be that the other zeros are out here? Is that possible? You look at that function. That's right. The leading coefficient is positive, so this thing's going to open up on both ends. Right? So there's no way it's going to go down over the x-axis and then back up. That's impossible. So long story. Huh? If they went down and then back up, we would have more than we'd have more than 4 zeros. Won't happen. Won't happen. So here's what we know. We know we have 2 real zeros, but we're supposed to have 4 zeros. Where are the other 2? They've got to be imaginary. Go right here. Make a list of the rational roots that the root theorem guarantees are possible. What are the possible numerators? Yep. Plus or minus 1, 2, and 4. What are the possible factors in that denominator? So let's write out the list. Plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 2 over 1, plus or minus 2 over 2, which is 1, which we already have. Let's see. I lost my place. Do we go to 4 over 1? And then plus or minus 4 over 2, which we already have. This is it. Now, I want you to look here. From this list, Which roots appear to be roots from the graph? You think 1 might work and -1/2 might work? Where are you lost? It's all right. Where are you lost? All right. Now what we're going to do is we're going to synthetically divide by these to verify that they indeed are roots. Okay? So let's do that. Which one do you want to start with? Which one do you feel the most confident about? I sure feel confident about 1. So let's do the synthetic division by 1. Let's see. 2, -1, 7, -4, -4. Bingo. Are you good that 1 is a root or a 0 of this function? Now we want to see what -1/2, was that the other one we had? Don't go back to the beginning. You can see is -1/2 of a root of what's left. -1/2 of 2 is -1. Bingo. Now, once I've done that division twice, look at what degree my function was, f, and tell me what degree this is. That's right, it's quadratic. And that's what's going to go right there. So let's see if we can find those other roots. If this is quadratic, I can find the roots of that thing, because if it's quadratic, by golly, if nothing else works, the quadratic formula will. What polynomial does this make? 2x squared plus 8. Set that equal to 0 and solve. Look, this is the square root of -1 times the square root of 4. What's the square root of -1? I. And the square root of 4? 2. So it's plus or minus I times 2, or 2I. So we found our 4 roots. 2 real, 2 imaginary.
How does that make sense though? Because I can't shift the graph down and make it half or
We have answered everything on that page. If it will let me go to the next page. Okay. I want you to take a minute and graph that function on your calculator. Now, when you graph it on your calculator, you're going to sketch it here on your paper. Do not, I repeat, do not start using your table and calculate and all that stuff to find those zeros. Just plot the ones that are really obvious and then sketch as best you can that graph. What does this look like? Because I have not graphed it.
Like a
Parabola-ish. So what are the zeros based on what you can see? You think there might be one at -1/4? Where's another one that you feel sure of? Please. 1/2? Here is all you can tell. You cannot tell me that that is -1/4 for sure, right? You, you stinker. So You've got one in this region, and you've got one kind of in this region. Is that right? That's all I want you to think right now. And then you said it looks like a parabola? The only things that are important are those right now. That's all I'm concerned about. Put them as close, approximately where you think they are. Now, on the set of axes to the right, draw the graph. Done. What conclusion can you make about the four roots? Why are two imaginary? Because it's a degree 4, so we expect 4 roots. We see 2. One is positive, the other is negative, and we know we have to have 2 more, so they must be imaginary. Why do we know the multiplicity of those? What do we know about the multiplicity? What's the multiplicity of each of the zeros we see on the graph? Why? Crosses smoothly. Crosses without changing concavity, right? Okay. Make a list of the rational roots that the root theorem guarantees are possible. All right. What are the possible numerators? Don't worry about the sign that it's negative 10. Just worry about the 10. What are the possible numerators? Plus or minus, go. 1. Stop. Okay. Possible denominators. Now, guys, we could write all of those out, but that's going to take us a bit. Can we just leave it right there for now? From this list, we may have to write them out. We're just going to see whatever you need. Which roots appear to be roots from the graph? Can you look at this and look at that graph? Give us some ideas about, from that list, what might that be? It might be a third, or negative. It might be negative a fourth. Are there any other options for that root? A 6? Oh. So, might be negative 1/4, negative 1/3, negative 1/6, right? Negative 2/6 is negative 1/3, goose. What about this one? Could be 2/3. 5/12. Yeah, 5/12. Could it be 5/12? I'm going to disagree. Why do I think it cannot be 5/12? Because more than a half. More than a half, so I'm going to veto that one. No, because we're on the positive side of the could negative 5/12. I think negative 5/12 is probably not, because I think that that's not very close to 1/2 or negative 1/2. You think maybe something got in the throat? 5/6? See anything else? I'd say it's probably bigger than 1/2, wouldn't you? Yeah. Okay, so we're going to stop here. Now, listen, these are the only ones we're even going to try. We're not going to try any of the others. In Algebra 2, especially if you were in pre-AP, didn't you just start and you just started trying them all? What we're going to call this group here, we're going to call those PRRs. Those are the possible rational roots. And we're going to call these highly possible rational roots. You're only going to worry about the highly possible list. The rest of it, all right. Where's your best guess? And you cannot say because you checked it already, goose. So, what's your best guess? Negative a fourth. So let's try negative a fourth. Now I'm going to have to go way down here because I don't have any more room. Negative 1/4. What are my numbers here? Goodness. 12. And we're going to pray for numbers that will divide by 4. Is that right? Well, it would help if I could add and subtract. 16, is that better? Negative 4. Woohoo! Woohoo! We got one. Now, here's the nice thing. Negative 1/4 works. How many negative roots do we know there are? Just one. I found it. I do not have to consider any more of those negatives. I'm only going to consider a positive. Which positive one do you want to try? I'd sure try 2/3. I sure would. Life is good. Life is good. Guys, here in pre-cal, we're not going to make P over Q a mess. This is it. What have we boiled this down to? We started with a, what do we start with? No, we didn't start with a quadratic. What's the word? Quartic. We divided twice, so we're down to a quadratic. Hey, 12x squared plus 24x plus 60. Let's find the 2 zeros of that. Shoot, that's easy. You dang right you can factor out a what? Let's do that. What do you see? That won't factor. So, quadratic formula or completing the square is easy because that middle term is even. You forgot how to complete the square, so that's what we're going to do. Okay. What about the 12? Why do we forget about it? Because I could divide both sides by 0 and get rid of it, or I could think 12 equals 0. That's stupid. Throw it out. So all we're concerned about here is x squared plus 2x plus 5 equals 0. Now, we're going to do complete the square because Jaylee forgot how. That's recorded for posterity. Okay. Remember, isolate the constant? Oh, that's the half it and square it thing? I don't remember. Well, let's do it. Let's do it. Completing the square is real easy if that middle coefficient's even. If it's odd, it's not. Half it and square it. But if you add 1 to one side, square root. What? Plus or minus 2i. There are two imaginary roots, and we had already found the two real roots. Okay, we've done it all. We're doing all right. Is this the last page? Okay. Based on the results of the previous pages, let's make a plan on how to find all the roots of a polynomial function. Step 1. Make your list of P over Q's. Step 2. Yeah, these are the possible rational roots, right? But I won't know the highly possibles until I do what? Graph it. Then we'll find the highly possible rational roots. What are we going to do with those? Yeah, synthetic division. With HPRRs until, how long do I synthetically divide? Till I get down to a quadratic. Till I get down to a quadratic. Until I'm left with a quadratic. Then, finally, solve the quadratic. That's going to be our list. Now, I do believe we have 2 problems there, and that's all we have left. Pick one. Okay, now Maribel says number 2 has a degree of 4, and all we've done is degree 4. So you want to do the degree 3? All right, fine. We'll do the degree 3. Question? What's option 1, or what's step 1? What do I find? P over Q. I'm going to find my possible rational roots. What's P? Over? Let's write them out just because you can. Plus or minus 1. 1/3. I'm going to go that way. I stay organized better. Plus or minus 2 over 1 and 2 over 3. Plus or minus 3 over 1 and 3 over 3, which we've already got. Plus or minus 6 over 1 and 6 over 3, which we've already got. What's the next step? Graph that sucker. I'm looking at a graph. I zoomed forward it. The graph that I see looks kind of sort of like that, sort of. Yeah, sort of. Would you say that that root is closer to -1 or closer to 0? Closer to -1. Now, does this make sense based on the function? My leading coefficient is positive and my degree is odd. What does that tell me about in behavior? Opposite. And when my degree is odd with a positive leading coefficient, down to the left, up to the right. Does that work? All right, so that seems to work. Okay, seems to work. So these, what do we call these? Possible rational roots. Now we're going after the highly possible rational roots. What would you consider them to be? -2/3? There. Wait a minute. How many roots do we have? 3. Where are the others? 2. And you think this is the only one that's highly possible? I agree. Go at it. Synthetically divide with that highly possible rational root. Did you get that? We started with a cubic, so this answer is a quadratic. 3x squared plus 6x plus 9, and once we get down to a quadratic, we just need to solve the quadratic. Indeed. Will it factor? No. No, if it was a -3, it would. I could complete the square because you all remember how. What do I do with this 3 right here? I could move it to the other side of the equation by doing what? Dividing both sides by it, which means 0 divided by 3 is just 0, right? So all I have to worry about is this x squared plus 2x plus 3. All right, let's complete the square because we can. Half of 2 is 1 squared. But if I add 1 to one side of an equation, this is times, not plus. This is I times the square root of 2. So your x equals -1 plus or minus I times the square root of 2. Now remember, that's only 2 of your roots. You had the other 1 already, right? And the other one was what, -2/3? Guys, the nice thing about the way we do P over Q in pre-cal is we look at the graph and narrow it down to highly possible instead of having to do a whole page, because that's a pain in the neck. Okay, I will give you your homework and I will see you physically. When will I see you again? I will see you Thursday.